Welcome to Let's Make Waves. I'm sure you have learned about waves before. What do you think of when you hear the word wave? Most people think about waves on the ocean. If you're a sports fan, you might also know the wave in a stadium like so. In science, waves describe many interesting phenomena. In addition to the usual waves on water, they describe the sound we hear, the light we see or don't see, the earthquakes we feel, tides, disturbances in gravity, and even matter itself. A wave is a disturbance which moves energy from one point to the other. You might have seen a wave on a slinky or a rope. You can send a bump down the slinky even though the slinky itself does not move with the bump. But how does this happen?
We can imagine the string as being made up of many small segments which pull on each other. When one end is pulled, the end of the string pulls on its neighbor, moving its neighbor with it. Then the next part pulls on its neighbor, which causes the next section of the string to move. Before you realize, you'll have a wave moving down the rope.
There are some words which we use to describe a wave more specifically. For example, we can talk about the amplitude and the speed of a wave. Let's first learn about the amplitude of a water wave.
The water here is still. There are no waves, and the water is in its rest position. Now when the water starts waving, we can measure the height of the wave from the rest position to a crest, which is also the same as the height from a trough to the rest position. This height is called the amplitude of the wave. On a wave diagram, the amplitude of a wave is the maximum displacement of the points on a wave from the resting position. The amplitude tells us how strong or intense a wave is. For example, louder sounds are accompanied by sound waves with greater amplitudes, while quieter sounds have lower amplitudes.
What about the speed of a wave? Let's look at the wave on a rope again.
Sent down a rope. We can measure how fast the wave is traveling by taking a point on the wave, say the crest, and measuring how fast that point is traveling. This property, which tells us how fast a wave is traveling, is called wave speed. But be careful, when we talk about the speed of a wave, we're not talking about the speed of the wave medium, but instead the movement of energy between the pieces of the medium. That transfer of energy is the wave. For example, with wave speed on the rope, we won't be interested in how fast any individual piece of the rope moves, but instead how fast this disturbance in the rope moves from one end to the other. If we look at a wave diagram, we can calculate wave speed by multiplying the wavelength and frequency of the wave. Different kinds of waves have different speeds fixed under specific conditions. For example, sound travels at around 343 meters per second in air, while the speed of light is much faster, and you will be finding this number in a later experiment.
In addition to amplitude and speed, we can also talk about the wavelength and frequency.
What is wavelength? Wavelength is the distance between corresponding points of two consecutive waves. What it means is that imagine you're at the ocean and you see waves flowing one after the other regularly. You notice the peaks of the waves, they have the same height. The distance between the peaks of the waves will give you the wavelength. The number of waves that pass a fixed point in a given amount of time is wave frequency. Basically, imagine there's a certain point in front of you and you have a whistle in your hand. When you blow the whistle, it makes a very high-pitched noise. A lot of waves are flowing to that certain point. This means that it has a very high frequency. Whereas if you're playing something like a drum, then it has a very low pitch. So less number of waves are flowing to that certain point, meaning it has a low frequency.
Amplitude, speed, wavelength, and frequency can tell you a lot about a wave. Now let's do some experiments to find out how they show up in real life.